All right, let's get into something that feels, well, fundamental. We all think we know how Windows works, right? You've got your desktop, your files, and of course, your drives. But what if I told you one of the most basic rules you know about Windows isn't actually a rule at all? You know this. C:\\. It's probably the first thing you see when you open up My Computer or this PC. It's the home base for your entire operating system. It's always there. It's always a letter. It's simple. It's predictable. Or is it? Okay, so what if a drive didn't have to be a letter at all? What if you could have a drive that was just a symbol? And there it is. That's not a Photoshop. Using a command that's been built into Windows forever, you can create a working drive using a plus sign. You can see it right there. We can navigate into it. We can use it, at least from the command line. This isn't some hack. It's a peek behind the curtain at how Windows actually sees the world. So, how on earth is that possible? Well, it's because the Windows you click on every day is kind of speaking a different language than the deep core part of the operating system, what's known as the kernel. Let's break down how Windows translates between these two worlds. So here's what happens. You type C/foo. That's what we call a Win32 path. But before the kernel can do anything with it, a part of Windows called an API steps in and translates it into something that looks like this. AAA/C/foo. That's an NT namespace path. That's the language the kernel actually understands. You can think of the NT namespace as the real, official map of everything running on your system. It's not just files and folders, it's all your devices, memory, everything. And it's all managed by a component called the Object Manager. This is the ground truth. And here's the biggest secret of them all. On that true map, your C drive isn't a fundamental thing. C is just a nickname. It's a shortcut, what's called a symbolic link that points to the actual piece of hardware, which has a much less friendly name like /device/HarddiskVolume4. Well, that changes everything, doesn't it? If C is just a convenient label, then what actually makes something a drive? We have to kind of redefine what we thought we knew. When you boil it all down, drive letters aren't some hard-coded law of Windows. They're just a convention, basically a habit, that grew out of that translation process we just talked about. The system is designed to look for a certain pattern, but what's inside that pattern is way more flexible than we've been led to believe. You see, when that translation API sees a path like +/foo, it doesn't panic. It follows the exact same logic it would for the C drive. It just slaps the //QQQ prefix on the front and hands it over to the kernel. To the kernel, C and plus are just names to look up in its map. So here are the real rules. A drive works if it meets 3 simple conditions. 1, it's a single character followed by a colon. 2, a shortcut with that exact name exists in that special // folder. And 3, that shortcut points to a real device. That's it. Any single character will do. Okay, but you knew there had to be a catch, right? Just because the kernel is cool with this doesn't mean every program you use is going to be. This is where the two different worlds of Windows, the kernel and the apps we use, start to clash. So old school tools like the command prompt, which talk more directly to those core Windows functions, they handle our ++ drive just fine. But newer, more user-friendly applications like File Explorer and PowerShell, they have their own, much stricter ideas about what a drive letter should be. They assume it has to be a letter from A to Z, and they just reject anything else. Yep. If you go and type +/ into the address bar in File Explorer, you're just going to get an error. Cannot find drive. It's a perfect example of an application enforcing a convention as if it were a hard rule, even when the underlying operating system is way more flexible. And you know, if you thought a plus sign was weird, hold on. We're about to go even deeper down this rabbit hole. Because if the rule is just any single character, well, that doesn't just mean ASCII characters. You are seeing that correctly. That is a working drive using the euro symbol as its letter. Or you could use a Greek letter or all sorts of other Unicode characters. As long as it fits that single character plus colon rule, the kernel and the command prompt are perfectly happy with it. This is where all those decades of software layers built on top of each other in Windows start to produce some truly bizarre results. What happens if we ask a different but still official part of Windows to do the same thing? Oh, this is just great. There's another way to create drives, using a specific function call. If you ask it to create a drive with the euro symbol, which has a character code of hex 20AC, it seems to just chop off the front half. It uses the AC part, which happens to be the code for the not symbol. So instead of an error, it just creates a completely different wrong drive. Amazing! And this isn't just a funny quirk, this stuff can have real-world consequences. For example, a programmer using a modern language like Rust might check if a file path is absolute. The language's own logic correctly sees c:\foo as absolute, but it looks at our +foo and our €foo paths and says, nope, that's a relative path, even though the Windows kernel itself treats them as absolute. That mismatch is exactly how subtle, hard-to-find bugs get created. So I know this seems like a really obscure piece of trivia, but digging into it actually teaches us some really important things about the software we depend on every single day. Let's talk about why this actually matters. What all this really shows is that modern software is like an archaeological dig. You've got all these layers built on top of each other over decades, and they don't always talk to each other perfectly. It proves that so many things we think of as hard rules are really just strong conventions. And it's a powerful reminder that old design decisions can have really weird consequences, and that making assumptions about how something should work is the fastest way to create bugs. And that kind of leaves us with one last thought. We just poked a hole in one of the most basic rules of using Windows. It really makes you wonder, what other parts of our digital lives, things we just accept as true, are actually just conventions waiting to be questioned? What other rules out there are merely suggestions?